Welcome to Train Signal. You're watching a video about networking command line tools. In this video, we're going to talk about and take a look at, well, you guessed it, some networking command line tools, including the Ipconfig, Ifconfig, and Arp commands. We'll take a look at the Ping and Arp Ping commands. We'll look at, hey, check this out, Traceroute and Traceroute. You'll notice one is Tracert and one is Traceroute, and we'll talk about the difference. We'll look at the Mtr command, the Netstat, NBTstat, and route commands, and finally the Nslookup, dig, and host commands. First, let's talk a little bit about Ipconfig, Ifconfig, and Arp. Now, I've grouped these together because all three are used to view some piece of the networking configuration. Ipconfig is used to view TCP/IP configuration in the Windows operating system. Now, we're going to take a look at Ipconfig in just a few minutes. We're going to actually go into the command prompt window and look at it, and you'll see that there's a number of different aspects of the TCP/IP configuration that we can view using this command. Matter of fact, we can even manipulate a couple things using this command. Now, Ifconfig is used for essentially the exact same purpose, except for it would be used on Unix, Linux, and Macintosh computers. Now, the Arp command is used to view and manage the Arp Cache. Okay, whoop-de-doo. What does that mean? Well, you may recall from a few videos back that we talked about Arp being the address resolution protocol, and that is used to resolve IP addresses to MAC addresses. Now, MAC addresses are the physical hardware address of the network card. Well, when that resolution takes place, the MAC address to IP address, or you could say IP address to MAC address resolution, is stored in memory for a certain period of time. And that area of memory is called the Arp Cache. Well, the Arp command is used to view and manage this cache. Now, we'll take a look at this command as well when we get into the command prompt window. Next, we have Ping and Arp Ping. Now, I have these grouped together because, again, they both serve a similar purpose in the sense that they both use to check connectivity between networking devices. Now, I want to clarify that networking devices, we talked about those in the past as being routers and hubs and switches and things like that, but all devices on a network are considered networking devices. So computers are also networking devices. And very often, that's what these commands are used for, is to check for connectivity between computers, or between a computer and a router, and things like that. Now, what's the difference between them? Well, Ping uses the ICMP protocol and uses the networking device's IP address to verify connectivity, whereas the Arp Ping command is used to check that connectivity using the MAC address. Okay, so it works a little bit lower in the OSI model. And really what it comes down to is if you are trying to check connectivity between devices and there is some kind of filter in place that doesn't allow ICMP communications, well, then you might need to use Arp Ping to check that connectivity. Now, there's a couple of drawbacks to using Arp Ping, and one is that it can only be used within a single subnet. In other words, because we are working lower in the OSI model, we're working at the data link layer and we're working with the MAC addresses, well, you can't go through routers. It's not routable. So you can only check connectivity within a single subnet. The other drawback is that it's not built in by default. You need to use a third-party utility which gives an interface to the Arp Ping command. So essentially, what are we really going to use when we talk about checking connectivity between computers or between networking devices? Is we're going to use the Ping command. And I will tell you, that's probably one of the most powerful yet simplistic utilities that you'll ever see. I mean, there's not a whole lot to ping. Ping is all about just saying, hey, can device A talk to device B? That's it. But at the same time, wow, how powerful is that? Hey, can device A talk to device B? When you're troubleshooting networking issues, ping will be one of your most heavily used utilities. And we'll take a look at ping when we get into the command line interface. Next we have Traceroute and then Traceroute. The Traceroute, where it's Tracert command, is what we use in the Windows operating system to view the entire path that a packet will take to get from one device to another. So Traceroute won't just show, hey, can device A talk to device B, but it'll show how device A is talking to device B. Maybe you have a computer on one part of your network, and then you have another computer that's clear on the opposite end of your network. Maybe 5 or 6 routers exist in between and have to be used to get from device A to device B. Well, the Traceroute command can show you what path device A is taking to try to communicate with device B. And it can also be used to show where there may be a failure of a device. And what I mean by that is not so much the failure of device A or B, but maybe the failure of a router in between. Maybe device A is sending the packet to router 1, who sends it to router 2, who sends it to router 3, who for whatever reason is not responding. Well, Traceroute would allow you to see that. Now, the Traceroute command, where route is spelled out, is essentially the same utility, but used by the Unix, Linux, and Macintosh operating systems. Whereas, again, Tracert is used by Windows. Okay, so now we have the Mtr utility. Now, this is a utility that is used by the Unix and Linux operating systems, and it's used to view the entire path a packet takes to get from one device to another. Now, that sounds a lot like Traceroute, right? But it also displays additional statistics about each node, and a node is another way for saying a router or some other networking device that you're going through, along the way. Now, the Windows operating system has a similar utility called Path Ping. But whichever one that we're talking about, Mtr or Path Ping, it's kind of like taking ping, which shows you kind of a real-time, are we making connectivity, and showing us some statistical information about that connectivity, and the Traceroute command, which shows us the full path, and putting them together to create a more powerful overall utility. So that's what the Mtr, and really Mtr and Path Ping commands are. They're like taking ping and Traceroute and putting them together, and boom, there you go. You have a really powerful utility. Now we move on to netstat, nbtstat, and the route command. Now I kind of stuck the route command in here, and I'll explain why in just a moment. It doesn't necessarily, actually really, these three don't even go together, other than the fact that they all display stuff. Now, Netstat is used to display TCP/IP statistics and connections to a given system. And we will take a look at the Netstat command when we get to the command prompt window here in just a moment. Okay, you'll see that there's a number of different switches that go with it, and I'll show you how you can see connections that are being made to and from a computer by using this command. Now, the nbtstat utility is specifically used for Netbios troubleshooting. Now, Netbios name resolution is kind of a thing of the past. There is still some Netbios name resolution that does take place in the background on certain systems. You may also have an older, a little more antiquated system that might still be using Netbios name resolution. But in either case, if you are, and if there's a problem with that Netbios name resolution, well, you can use nbtstat to go ahead and look at Netbios information about a computer to try to help troubleshoot those problems. Now, the route command is something that we already looked at in a previous video. In the routing video, we took a look at the route command, and we saw that it is used to display a computer's routing table and can also be used to modify a computer, and really I shouldn't say a computer, any networking device's routing table. So we'll go ahead, we will take another brief look at the route command once we're in the command prompt window. Now, the last few tools that I want to talk to you about before we get into this command prompt window are the Nslookup, the dig, and the host commands. Now, I have these all together because they all relate to DNS name resolution and DNS statistics and DNS lookups. So here's the breakdown. Nslookup, which is probably the most well-known utility out of the three, is used by, now I have it listed here as used by the Windows operating system, but I want you to hold that thought for just a moment. It's used by Windows to help troubleshoot DNS name resolution issues. Nslookup, one of the really neat things about this tool is that it has both an interactive and a non-interactive mode. Now, what this means is you can either use the Nslookup command with some switches after it, and I'll explain to you what a switch means when we get into the command prompt window, but you can use it with switches to get immediate results, and that would be non-interactive mode. Or you can actually just type the command Nslookup all by itself, and that will take you into an interactive mode, which will then allow you to continue to type additional commands within the utility to continue extracting information. Now, I'll show you the Nslookup command. I'll show you the difference between interactive and non-interactive in the command prompt window. Now, the dig command is used by Unix, Linux, and Macintosh operating systems for essentially the same purpose. Now, the dig command does not have an interactive mode. The dig command only has the non-interactive mode. Now, you'll notice here that now we're going to come back and I'm going to tell you that Nslookup can also be used by Unix, Linux, and Macintosh. So even though I have Nslookup listed as being used by Windows operating system, it's really used by all the operating systems. I just wanted to break apart that the dig command cannot be used by Windows. Maybe that would have been a better way to put it. Is Nslookup used by everybody? Dig cannot be used by Windows. So dig is used by Unix, Linux, and Macintosh, and I'll tell you what, even though it does not have an interactive mode, it is considered to be more powerful. It has some more flexibility. It has some more capability. But I will also tell you that typically when administrators are looking to do this sort of troubleshooting and DNS lookups in an interactive setting, they'll use Nslookup no matter what operating system they're using. Now, the last utility I have here is the host utility, which is used exclusively by Unix and Linux, and it does reverse lookups on an IP address. Now, what do I mean by reverse lookup? Well, let's talk about lookups in general. When we talk about DNS lookups, Netbios lookups, what I mean by lookups is that basically humans, or as I sometimes refer to us as stupid humans, don't like to have to work with numbers and dots and, not IP addresses. Right? When you want to go to a website, you don't want to type in a bunch of numbers and dots. You want to put in a name that is familiar to you. Well, computers don't work with names. They don't communicate using those names. They communicate using IP addresses. So a lookup needs to be done to say, okay, here's the name. Let me look up what IP address that is. Well, a reverse lookup would be the opposite. It would be where you have the IP address already, and now you want to see what the name is behind it. Or more specifically, with the host command, it would be finding out what the host name is behind the IP address. And the reason I emphasize host name is because we also have Netbios names. And this has nothing to do with NetBIOS names. It has to do with only the host name. Now, if you were trying to do this same type of reverse lookup of an IP address in Windows, well, you would just simply use the Nslookup command, because part of the Nslookup command is giving you the ability to do not only forward lookups, but reverse lookups as well. Alright, well, that's enough talking about these different commands. How about we go ahead and take a look at some of the commands we were just talking about. So what I'm going to do here is go ahead and click the Start menu, and then, because we're working with Windows XP, I'm going to go ahead and, well, I need to go to the command prompt. Now you'll notice that because I've accessed it recently, I'll see it on my menu right here. But in case you don't have it on your menu, there's a couple other ways you can get to it. The way I like to do it is by clicking the Run command and then just typing in CMD and click OK. This will go ahead and open up a command prompt window. Now, the first command that I would like to show you is the Ipconfig command. Now, if I just type in Ipconfig, okay, which is Ipconfig, and hit enter, you will see that I get a basic display of my Windows TCP/IP configuration. It shows me my IP address, which is 192.168.10.236, my subnet mask of 255.255.255.0, and my default gateway, if one is configured, which in this case is 192.168.10.200. So those are the absolute basics about how my computer is currently configured. But there's a lot more that we can do with the Ipconfig command. And the way we do it is with something called switches. Now a switch is where you, let me go ahead and type in Ipconfig once again. It's where you add additional information to the tail end of the command to add additional functionality. And one of the really cool things about working with command line tools is that if you ever forget how to use the different switches, you can always hit / and hit enter, and you will get a help listing on exactly how the command is used. And you'll notice right up here at the top, you'll see that there's a number of different switches that we can use. I can use Ipconfig, well, /, which we just did, but we can also do Ipconfig /all, /renew, /release, flush DNS, display DNS, register DNS, show class ID, set class ID. Okay, so there's a number of different things we can do with the Ipconfig command. Now, down here, they display a little bit more information about what each of these switches mean. So let me just kind of go down the list real quick with you. Ipconfig /all displays the full configuration of information. So in just a moment, we're going to do that command so you can see what the difference is between just Ipconfig and Ipconfig /all. Now, Ipconfig release and renew, I'm going to talk about those together. Those have to do with working with the DHCP server. If you are doing automatic IP addressing, and I'm not talking about a PIPA, but where you're dynamically getting your IP addressing on your clients, and you're getting that IP addressing from a DHCP server, well, if you ever want to let go of your IP address and give it back to the DHCP server, you do an Ipconfig /release. And when you want to get a new IP address from your DHCP server, you do an Ipconfig /renew. So if you ever hear anybody say to you, oh, just do a release and renew, or sometimes they'll say, do an Ipconfig release and renew, or sometimes they'll say, do a DHCP release and renew. There's many different ways that administrators will say this, but that's what they mean. They mean to type in the command Ipconfig /release and hit enter, and then follow that up by saying Ipconfig /renew. And this is done when there's a problem with the IP address that you currently have on your machine. Now, the next three commands I'll kind of bulk together. We have Ipconfig /flush DNS, register DNS, and display DNS. And these all have to do with, well, You probably guessed it, DNS. When you do a DNS lookup, when a computer does a DNS lookup, so I'm not talking about something you manually do through Nslookup, let's say. In other words, when a computer is tasked with looking up an IP address for a certain host name or a DNS name, so maybe you've asked to go to a certain website, and the computer now needs to resolve that name that you're looking for down to an IP address. Well, it stores that IP address or that resolution, that name and IP address, in memory, and that little area of memory is called the DNS cache. Well, if you want to flush out that cache, you want to erase that memory, maybe there's a problem. Maybe you did a lookup and you resolved a name to a certain IP address, but since then, the IP address has changed for that particular computer name, and you've still got it stuck in your cache. Well, you can do an ipconfig/flush DNS. Register DNS is when you want to force your computer to register itself dynamically with a DNS server. So if you're using a DNS server for this name resolution, and if you are using a client that does dynamic updates, and really if the server supports dynamic updates, you can tell the client, go out and register yourself with that DNS server with this command. And the last one, display DNS, well, it means just that. It displays the DNS cache. It will show you the named IP address resolutions that are currently being used on your system. Now, the last two on the list here, show class ID and set class ID, well, this actually takes us back to DHCP, but it puts us into a whole different area of DHCP. Matter of fact, it puts us into an area that is very, very seldom used. These are probably the switches that you need to know the least about. And what this has to do with is DHCP has the ability to go ahead and assign different TCP/IP information to different clients based upon a certain class of that client. So, set class ID allows you to set the class ID on this client, and show class ID allows you to see what class ID has been set for this client. Now, don't worry about that. Don't worry about knowing what these classes are and what these class IDs are. Just wanted to show you that this is some of the additional capabilities that are built into the Ipconfig command. All right, what I want to do now, well, first thing I want to do is I'm going to type in a command, which we haven't talked about, and it really has nothing to do with networking at all, but I'm going to type in CLS, and that stands for clear screen, and hit enter. And it does just that. It clears all the junk off the screen. And I wanted to do that so that we're not confused here. Now, you remember when I typed in ipconfig all by itself, we just saw IP address, subnet mask, and default gateway. Well, what I'm going to do now is I'm going to type in ipconfig/all and hit enter. And boom, you'll notice that we get a lot more information than we had previously. I mean, we still have right here our IP address, our subnet mask, and our default gateway. We still have those three pieces of information, but we have a lot more. We have the host name of this computer. Now, I'm not going to go through every single line item here, but I'll show you some of the items that we've talked about. If we actually, let's go down to the bottom half here, and you'll notice that we have right here, it says physical address, and here is a hexadecimal number, which means we have 16 possible characters that we can use, which are 0 through 9, and then A through F. So that's why you see numbers and letters here. So we have 00, 0C, 29, 28, A7, 0E, and that is the physical address or the MAC address of this particular network card in this computer. You'll see that we are using DHCP, so I am a dynamic client. Besides our IP address, subnet mask, and default gateway, we can also see what DHCP server has given me my IP address, and you'll notice that it's the same IP address as my default gateway. And you may recall from a previous video that I showed you the wireless router that I'm using here in my office, and I showed you how that router was also acting as a basic DHCP server. And so that's what we have going on here, is that that router is also my DHCP server. And then we see the IP address. Matter of fact, we see two IP addresses of the two DNS servers that I use to do DNS name resolution. And actually, right down here at the very bottom, you'll see here we have lease obtained and lease expires, which shows us when we got the IP address from the DHCP server and how long we get to keep it before we have to go out there and renew it again. So that is how Ipconfig can be used to not only display information about your system, but to also control certain things like releasing and renewing your DHCP address and managing your DNS cache. So let me go ahead and type in CLS to clear the screen once again. And let's go into the next command. The next command that I want to show you is the Arp command. So ARP, and I'm going to put in / right out the gates, because I want to show you that there are a number of different commands, or switches I should say, that you can do with the Arp command. -A displays the current Arp entries. Okay, so -A is going to display the Arp cache. A couple other popular ones are -D for deleting an entry in the Arp cache, and -S is a way of adding an entry into the Arp cache. And see, this is kind of interesting because a lot of people are like, huh? Why would -S be for adding? Right? Wouldn't -A be for adding? Well, -A is for looking at the Arp cache, and -S is for adding. And the reason why is because typically the Arp cache is modified dynamically as IP to MAC address resolution takes place on a network. But if you know that there's a very specific entry that you want to put into that cache, it's what's called a static entry, and that's why it's -S. Okay, so let me go ahead and type in, well, let me clear the screen, and let me type in Arp-A. And you will notice that apparently there is only one other computer that I have recently communicated with, and that's a computer who has the IP address of 192.168.10.222. And here's the actual physical MAC address that that particular computer uses. And you'll also notice that it says that this is a dynamic entry. Okay, this is an entry that was made just through the normal course of communication. Now, if I were to go ahead and, I know we're kind of jumping ahead in commands here, but let me type in ping, and I'm going to put in 192.168.10.200. Now, we'll come back to the ping command. I'm not really doing this to show you this command yet, but let me hit enter. The reason I'm doing this is because I wanted to force communication with that particular IP address. And the reason why is because I'm going to do an Arp-A once again, and you'll notice that I now have another dynamic entry for that particular IP address. Just by having communication on the network, there is an automatic process that takes place, and that process is done through the address resolution protocol of resolving the IP address down to the physical MAC address. Now, I will tell you that these entries don't stay very long. As a matter of fact, if there is no additional communication with either of these machines, the entries will only stay for 2 minutes. And even if there is ongoing communication with these other computers, the entries will automatically delete themselves after 10 minutes, and then we'll have to do the resolution again. So let me actually, just for kicks, let me do a -A again. Now, sometimes I can get lucky, and if I do it again, and if you're following along, you can periodically just keep hitting the command, and you'll notice that some of these entries may disappear. Okay, it looks like right now they're not going to disappear, they're going to stick around. There is obviously some communication taking place between this computer and these other computers. It probably hasn't even been 2 minutes since I pinged the 10.200 router. But if you want to create a static entry, and let me go ahead and do Arp-? once again, and the reason why is because you'll notice right down here at the end, they give you an example. You would put in Arp-S space, the IP address, space, and then the MAC address. So let me try that. I'm going to put in arp-s space, and let's just make up an IP address here. We'll say 192.168.10.123. And we're going to say that that has a MAC address of 00-11-22-33-44-55. Now, none of this is real. This is strictly hypothetical. I'm going to go ahead and hit enter. And then I'm going to go ahead, let me clear the screen. I'm going to hit arp-a again. Hey, look at that. You'll notice that apparently 2 minutes has passed and I haven't communicated with 10.200 or 10.222. They're both gone, but now we have that entry that I just created and it's listed as static. And that static entry will stay indefinitely. It'll stay until I manually delete it. Now, just out of curiosity, let me see if we can get another one to show back up. No. If I ping 192.168.10.200, okay, so I have connectivity with that particular computer, and if I do an arp-a now, and actually let me clear the screen, do it again, arp-a, there we go, you can see I have the two entries. If I'm ready to delete an entry, well then I'm just going to put in arp-d and put in 192.168.10. Well, let's actually do 200. Even though that's the dynamic entry, check it out. I can delete it. Even if it's a dynamic entry, I can still get rid of it. Now, if I do that same command again, arp-d 192.168.10.123, clear the screen, arp-a, check it out. No ARP entries found. Why? Because I deleted all of them. So that's the ARP command, and that's how it's used. Now, this takes us into the ping command. Now, I already showed you ping, right? If I just do ping space and then put in an IP address, oops, there we go. You can see that it says that we're pinging that IP address, and this is what we hope for. We want to see replies from that IP address. Now here's the real overly simple version of how ping works. Basically what just happened is my computer sent out a tiny little packet out to, in this case, the router that I'm connected to, my default gateway, and it just says, hey, I'm trying to see if I can communicate with you. If you hear this, please send something back to me. So when you ping something, you're sending out what's called an echo request. Okay, you're making a request for an echo. You want them to say something back to you. Okay, just like an echo, if you're in a canyon, you're going to say hello, and you hope that you hear hello back to you. Or notice it comes back 4 times. It's kind of like hello, 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 hello. So that's the echo reply coming back, these replies that we see here. That right there, if I didn't tell you anything else about ping, that one command all by itself can be amazingly powerful. When somebody says to me, hey, I can't see the such and such server, right? Someone says to me, I can't see the file server. You know what I say to them? I say, can you ping it? And they say, can you what it? Because they don't know what the ping command is. But that's why I'm asking, can you ping it? Is because just because somebody says they can't see something doesn't truly mean that the computers can't talk to each other or can't communicate with each other. It means that they can't see it through whatever interface they're used to seeing it. The ping command will validate whether there is connectivity or whether there's a problem with connectivity. Now another thing that we can do with the ping command is we can ping by name. And this will help show if name resolution is working or not. If I were to ping, let's put in www.google.com. Okay, you'll see here that it's resolving to an IP address first and then sending out those pings. Now, if I was not able to communicate with this particular name, there's 2 potential issues, and I need to pay attention to which one is failing. One issue is I could get a response back that says that the name couldn't be resolved. And then we have a name resolution issue. Another possibility is it might come back and say pinging, and then it'll resolve to an IP address, but then we don't get these replies. And that could be a communication issue, or it could still be a name resolution issue, meaning maybe we have the wrong IP address. Now, if we were to send out a ping, let me clear the screen. If we were to send out a ping and we send it to a computer that's not there, again, here's a made-up IP address. I don't believe there's a 123 on my network. Let me hit enter. Okay, you'll see it's attempting to ping, but look what happens. We're going to get request timed out. And the reason we get a request timed out is because my computer right now is sending out that echo request saying, hey, 192.168.10.123. If you're there and you can hear this, send a reply back to me. Well, I'm only going to wait for so long. And after I'm done waiting and I don't hear anything back, well, then I'm saying, nope, no communication. That request has timed out. Too much time has passed and there's no response. But that's not the only negative response that we could get. There's also another message we could get back saying the destination host is unreachable. Or just to be more specific, it'll just say destination host unreachable. And what that means is that basically this computer was not able to find an appropriate route to that destination device. Okay, in other words, when looking at the routing table, or possibly not just this computer, but maybe this computer has a default gateway, and then when you get to the default gateway, it doesn't have an entry in its routing table that matches that particular network. Well, then you get a response back that says destination host unreachable because it doesn't know how to send that echo request all the way to the destination. Now again, you can also get an unknown host response, and that very often has to do with when the name cannot be resolved to the IP address. You can get expired TTL, and TTL stands for time to live, and this just basically has to do with too many hops are needed to get from point A to B, or from A to B and then back to A. And so basically there's a lot of different things you can do with ping. Now ping also has a number of different switches. So if I do ping /?, you'll see that there's a number of different switches that you can use, and you can get real sophisticated with this ping command. You'll notice that you can control how large a request packet you're sending out there. You can change the time to live. You know, maybe you're getting a time to live timeout. Well, we want to go ahead and extend that. You could extend or change the timeout value and how long you want to wait to hear back from the destination. But I'll tell you what, one of the most commonly used switches, it's one that I use all the time, is the one that's listed right at top, -T. Now you may have noticed that when we did the ping command, we always got 4 replies. Or even when I did it to an IP address that didn't even exist, we got 4 request times out. Well, that's the default. And that's basically, you don't want to have just one, because there could just be one simple hiccup on the network, and then boom, you get a request timeout, and it's like, hey, we can't talk. No. We want to have at least the 4 so that we can say, all right, we really aren't talking, or we really are talking. But what I'll do sometimes is I'll go ahead and say ping and put in an IP address, and if it's getting a request timed out, I'll put in the -T. Now in this case, it's a bad example because this is not a computer that truly exists. But you'll notice that these request timed out messages are just going to keep coming. They're going to keep coming indefinitely until I stop them. And the way you stop them is with a break. And the way you do a break, or the way I like to do it, there's a couple ways to do it. I like to do it by hitting Control-C on the keyboard, which I'll do for you in just a moment, but I want you to see how this request timed out is just going to keep coming through. It's just going to keep coming, keep coming, keep coming. All right? So we can see there's more than 4 there, so I'm going to hit Control-C, break out of it. And I'll tell you what, if I would have done a ping, and let's do an IP address of a computer that we can communicate with. Now it goes a lot faster because we're getting the replies, and you can see how it's just going to keep going and keep going. And the thing that's kind of cool here, and where I've used this, is if you seem to be getting a lot of hiccups on your network where you do have connectivity but it seems to be sporadic, this is a great way to just kind of go through and look and see if maybe we're getting reply, request timed out. Okay, maybe you have that delay and then request timed out. And then you go back to getting replies again. Or maybe here where you can see the time to get these responses, you'll notice I'm getting 1 and 2 milliseconds. It's very fast. Why? Well, this computer's sitting right next to the router that we're pinging right now. And there's all of about probably a 3 to 5 foot cable that is connecting the two. So we're getting very fast responses. Well, maybe I start noticing that those milliseconds, maybe I start seeing 1 and 2, but then every once in a while I see 100, 200, 300, 500. Suddenly I see the response time, even though I'm getting replies, they're very lengthy. That again can show me that maybe we're having a bit of an intermittent problem. Now let me go ahead and break out of this. But very often where I'll use it is when I'm not getting connectivity with something that I should be having connectivity with. I'll do the -T while I'm troubleshooting the network so that on my screen I can see when connectivity has been restored. Now the next command I want to show you is the Traceroute command, and because this is Windows, it's going to be trace and then just RT. Matter of fact, when I was in class a long time ago and I first learned about this command, I had a student who was sitting next to me who insisted that the name of this utility was Traceroute. If Traceroute is how you remember it, great. But really, it's Traceroute, because that's what we're doing. We're tracing the route to get from point A to point B. So what I'm going to do is I'm going to do a Traceroute and then put in, well, let's go ahead and do www.google.com, right? We know we made connectivity with that particular website, so I'm going to hit enter. And you'll notice that what it's doing is it's showing me all the different hops. Okay, first it says here's the destination, right? It resolved this IP address. And what we have here is that we're going to start off with the first hop being 192.168.10.200. And I apologize, it's still moving on the screen while I'm talking here. And that is, well, this computer's default gateway. Then from there, the next hop was 192.168.13.254, and I'm about to lose this off the screen. Oh, there we go, it completed. Let me scroll up a little bit. And that happens to be another router that we have on our network. In other words, my router that I have here in my office has established the 192.168.10 subnet. But outside of my office, but still within train signal, we have another router which has been set up establishing the 192.168.13 network. And then from there, you will notice that we go outside of our network. We go out to Comcast, which is our internet service provider on this particular line. And then you'll notice it's bouncing around through a bunch of Comcast routers. And then you'll notice that it goes even beyond the Comcast routers and goes out on the internet and just kind of goes through the internet to eventually get to the web server at Google. Isn't that pretty cool? Now, this may not tell us a whole lot, or do much for me, I really should say, when trying to troubleshoot connectivity to Google, because, well, there's not much I can do with all these different internet routers. But within your own network, if you have a highly routed network, you have a large network, and you have all these different routers, and you're trying to figure out how device A over here is getting to device B way over there, Traceroute's a great way to see what's happening. Maybe you'll get users in one office who are telling you that it seems like communicating with this one other office is really slow, and you're not sure why. Well, you can do a Traceroute which will show you that maybe your routers have been misconfigured to send a user in the one office zigzagging around to 18 different routers when maybe they could have just used 2 or 3 different routers to get there. So maybe you go ahead and reconfigure some of those routers to create shorter paths. Okay, so that's how the Traceroute command works. Let me go ahead and clear the screen out here. Now, the next command that I want to show you, and I'm just going to show you this real briefly. Matter of fact, there's two more commands I want to show you, and I'm going to show you kind of a brief version of them because I just want you to have the general idea. And that would be the Netstat command. Now, the Netstat command has a bunch of switches that goes with it. Okay, and you'll see here that -A displays all the connections and listening ports to this particular computer. -B, all the executable involved. -E, Ethernet statistics, etc., etc., etc. You'll see that there's a lot of different switches, and they all have to do with displaying different statistics. Matter of fact, you'll notice -R displays the routing table. And before we go any further, even though this is not the main purpose behind showing you this utility, notice that if I type in netstat-R, it pulls up my routing table. And you may recall from the routing video, that's the exact same thing as the route print command. Okay, I know it might look like nothing happened, but if I scroll back up here, you'll notice I now have two routing tables. Okay, they're exactly the same because, well, it's my routing table. I can actually view it using the netstat command. Now let me clear out the screen. If I type in netstat-A, okay, you'll notice that, well, there's not a whole lot that you can see here, and don't worry about the fact that you're seeing the word video here. That might seem confusing, but that's the name of this computer. This computer's name is Video, because I'm using it to create these videos. So don't take the word video as being literal. That's computer name there. And you'll notice that there's a few ports that it has open right now. And it's a very minimal list. Whereas, check this out. If I were to go ahead and open up Internet Explorer, and I were to type in, let's go to Google as a for instance, and then go back here and type in the netstat-A command again. Okay, now you'll notice there's a couple of extra entries for the connectivity with Google. Now another command that you could use as a for instance, or another switch, would be netstat-O, which just shows you the active connections. And you'll notice that there are no active connections. And that's only kind of semi-true, because you'll notice I still have Google up on the screen here, but it seems as though there should still be a connection there, but there's not, because you only keep the connection for a short amount of time. I mean, this text can stay up on the screen forever. I'm not still continually connected with Google's web server. Google's web server is going to go ahead and kick out the connection after a very short amount of time. So let me go ahead and refresh this, and then come back down here to my command prompt window and type in netstat-O once again. And now you'll notice that it's showing the connections with Google. Now to be more specific with that -O switch, I could put -O space, and I'm going to put in 5. And that stands for the number of seconds that I want to periodically check. If I hit enter, you'll notice that it shows me, but it doesn't take me back to the command prompt, because in 5 seconds, oh, there it goes, it shows me again. And in 5 more seconds, oh, there it goes, shows me again. Now in the meantime, if I were to come back over here to my Internet Explorer window, and let's go ahead and connect to train signal, and come back here, okay, now you'll notice that we have even more connections. We have Google and train signal. And if we come over here and we go to Microsoft, come back over here, oh, now we're really getting a lot of connections going on. Okay, so as I create network activity, I can go ahead and see those additional connections being made through the netstat command. So go ahead and close my Internet Explorer browser, and you'll notice that almost instantly the active connections went away, because I don't even have the Internet Explorer browser window open, so boom, it just closed all those connections. Now there's still one connection that it's showing here, and it's because it was a wait connection, and that wait connection is going to basically sit out there until it times out. Yeah, that had to do with one of the websites. I don't even know which one. I apparently was waiting for a response and I didn't get one, and that's not that unusual. So the Netstat command can be used to display connection information to a machine. Now let me go ahead and hit Control-C, which will break me out of that, and I'll type CLS for a clear screen. And the last command that I want to show you here is Nslookup. Now here's the thing about Nslookup. You have the ability to use it either interactively or not. So if I type Nslookup, and I'm going to go ahead and put in, well, let's go ahead and put in www.google.com like we've done before, and hit enter. Okay, now that was an example of non-interactive. Okay, because we went ahead and just typed in the command and it really wasn't so much a switch as much as some extra information after it. Now you can also do switches. And then I went ahead and I was able to find out that Google resolves to a number of different IP addresses. Now don't worry about some of these errors that I'm getting up here right now, and on your end, if you're following along, you might get some similar errors, and that has a lot to do with the overall DNS configuration within your own network. And I'll tell you what, I could talk to you for hours in another video about nothing more than just DNS. So I'm not really focused on you becoming an expert in DNS right now. And I don't want you freaking out if you're thinking, oh, what is all this DNS stuff? I don't get it. I don't know what this is. That's okay. Just understand that Nslookup is used for DNS lookups. Now if I want to use Nslookup interactively, then I'm just going to type in the Nslookup command all by itself and hit enter. And you'll notice now that I have a slightly different looking command prompt, and that's because I'm in the Nslookup utility. And if I type help, I can get help for all the different things that I can do within the Nslookup utility. Okay, and you'll see that there's a lot of them. And you know what? There really is a lot of them, and there's a lot that you can do with this. And I really don't want to overwhelm you right now with all the different things you can do with Nslookup. Okay, it's just, we could talk for hours. I just want you to understand that Nslookup is used for DNS troubleshooting. It is a very powerful tool. It is a very detailed tool. And it can be used very quickly in a non-interactive fashion. And it could also be used in detail, in sophisticated detail, in an interactive fashion. So I'm going to go ahead and I'm going to type in exit, because you'll notice right down here, exit exits the program, just so I can show you that we can get out of interactive mode and go back to our regular command prompt. Alright, well, that's pretty much it for command line tools, and after watching this video, well, you should be able to describe what some of the various command line tools are and when they would be used.